This is the 7th video in an overview series of the first 3 chapters of the book From Quantity to Number, our first course in mathematics. From Quantity to Number is a book for parents and students interested in a discussion-based math program for their homeschool curriculum. For more information, see inletbooks.com. In this video, we'll continue and wrap up our discussion on addition. As your students become more comfortable working with numbers and adding numbers, one way to consolidate understanding is for the student to search for patterns. There are lots of ways to go about this. To begin with, you might simply start counting by your favorite number or any number and notice the pattern. For example, let's look at counting by 8. 1 8 is 8, 2 8s, 8 plus 8, that's 16. 3 8s, 16 plus 8, that's 24. 4 8s, 24, and one more 8, 32. 5 8s are 32 plus 8, or 40. At this point, we have several blocks of 8s to work with. So, for example, if we wanted 10 8s, we can now count 5 8s plus 5 8s, that's 40 plus 40, or 80. In a similar way, students might discuss other numbers to build up with the blocks determined so far. For example, we can count 9 8s as 5 8s plus 4 8s, 40 plus 32, that's 72. And we can go on combining our counts of 8s in this way for any number of 8s that we want to count. This is a good exercise showing the practice of breaking down a bigger task into manageable, smaller tasks. Here, it's in the forms of counting 8s with blocks of 8s that we know. Notice that this simple counting exercise also lets the student develop spontaneously the idea underlying multiplication. The book covers multiplication in great detail in Chapter 4, but this little exercise will familiarize students with the idea beforehand. You can discuss these kinds of patterns and the structures they show with any number of numbers, and you might even use these discussions as an opportunity to introduce the multiplication notation, which can be thought of as a shorthand for repeated addition. 4 times 8 means literally count 8 4 times. Another interesting and useful structure to notice in numbers is that every positive whole number is either even or odd. An even number is any number that can be counted as 2 equal whole numbers. For example, 6 is even because it can be counted as 2 3s. 3 plus 3 equals 6. A number that is not even is called odd. 7 cannot be counted with 2 equal whole numbers. 3 plus 3 is 6, but 4 plus 4 jumps over 7 to 8. 7 is odd. Even numbers are useful when we would like to break a number into 2 equal whole numbers. A good topic for discussion could be to ask the student to think how to describe the even numbers based on the definition we just mentioned. The answer is that the even numbers can be thought of as the numbers that we can count by counting 2s. 2, 4, 6, and so on. In a similar way, we might describe the odd numbers as adding 1 to the counting of 2s, including 0 2s to count 1 with the addition of 0 plus 1. This kind of exercise, describing how to build the even and the odd numbers, is a good practice, by the way, to prepare for later work where we will describe processes for constructing numerical patterns or where we will find mathematical expressions for numerical structures that we are interested in building. Another way to study structure in numbers is to take up any number and explicitly break it down as a sum of powers of 10. In Chapter 1, we developed counting so that students could be comfortable understanding and working with numbers into the millions. So this is a review of sorts that also connects the addition discussions with the discussions in Chapter 1. For example, you might consider any 6-digit number and ask your student to describe it as a sum of powers of 10. 807,242. In this view is 800 thousands plus 0 10 thousands plus 7 thousands plus 2 hundreds plus 4 tens plus 2 ones, for example. If your students like symmetry in numbers, they might appreciate working with and describing numbers like 8,008,008. In any event, there are lots of fun numbers to play with, and they offer great opportunities for exploring structure and pattern in numbers. Even with the elements we have studied so far, there is a lot to explore through discussion and thinking that is useful and interesting in developing familiarity with numbers and arithmetic.